Welcome back. In this particular session, we will be discussing in detail about the another type of chemical reaction, redox reactions. Now, if you look at the word, we can split redox into the first part, that is reduce, which is your reduction reaction, and ox is your oxidation reaction. First, we will discuss about oxidation reaction and reduction reaction. Once we understand that, we will understand redox reaction. So let us start with oxidation reactions. As the name suggests, oxidation reaction are a type of chemical reaction where oxygen is added or an electronegative element gets added. Let's understand with an example. In the experiment where we burn magnesium ribbon Mg in the presence of oxygen, we get magnesium oxide. Now, here oxygen is getting added to magnesium, therefore this is an example for oxidation reaction, and in this reaction we can say that magnesium is getting oxidized to magnesium oxide. Let us take another example for oxidation, which we commonly see in our day-to-day life. When we place an iron metal outside, we know that it reacts with Fe, iron reacts with oxygen to give us ferric oxide, Fe2O3, or iron. In this reaction also, oxygen is being added to iron, meaning iron is getting oxidized. This is an example for oxidation reaction. So, oxidation reactions are a type of chemical reaction where oxygen or any electronegative element is added. Speaking about reduction reaction, reduction reactions are the opposite of oxidation reaction. In reduction reaction, oxygen is removed or electronegative element is removed, and on the other hand electron is added. So those are your reduction reactions. So let me write an equation to further elaborate. We have copper oxide, CuO, which is black in color, black copper oxide. Now if you pass hydrogen gas H2 through this copper oxide and heat it, you get your copper back and water, because copper being more reactive than less reactive than hydrogen, it is getting displaced, so you get water. So this is an example for reduction reaction where in the beginning we had copper oxide, the product is copper, which means that oxygen has been removed, which is then nothing but your reduction reaction. Oxygen is removed. Reduction can also mean hydrogen is added. For example, hydrogen was added to oxygen to give you water. So now, in nature, oxidation and reduction reactions usually they occur together, they occur simultaneously, and when both oxidation and reduction reactions take place simultaneously, such type of chemical reactions are called as redox reactions. Very simple. Another example, that is zinc oxide plus carbon. Zinc oxide plus carbon. What does it produce? It produces pure zinc and carbon monoxide. Carbon monoxide. Now, in this particular equation, we have to identify which is the oxidation reaction and which is the reduction reaction, remembering our definitions. So, let us see. Initially, we had zinc oxide, which you can see zinc oxide is now being converted to zinc, which means that oxygen is removed, and reactions where oxygen is removed are called as reduction reactions. So this particular portion is an example for reduction reaction. Automatically we can see that the oxygen which was removed is added to carbon. So carbon is getting oxidized. Carbon is getting oxidized. Oxygen is added. Therefore, this particular portion is our oxidation reaction. So when both reduction and oxidation take place together, such reactions are called as redox reactions. We have to discuss two important terms. One is oxidizing agent. Oxidizing agent. Another is reducing agent. Now, what do you mean by oxidizing agent? Very simple. Any substance or compound that produces or provides oxygen is an oxidizing agent. It will produce oxygen for the reaction. Reducing agent is the one which will accept the oxygen, is a reducing agent. So let us identify in this particular equation which one is the oxidizing agent and which is the reducing agent. Very clearly we can see that zinc oxide is the one which is providing oxygen. Therefore, zinc oxide in this case will be our oxidizing agent, which we will show in short form as OA, oxidizing agent, and reducing agent will be RA. So zinc oxide is our oxidizing agent. Automatically carbon will become the reducing agent. Now if you observe, redox reactions are very easy. If you are able to identify any one of these, either oxidizing agent or reducing agent or oxidation or reduction, you can find all four. Take for instance this particular equation. Here we saw that zinc oxide loses oxygen, therefore it undergoes reduction reaction. The compound that undergoes reduction will be a oxidizing agent, reverse, and the compound or the element that undergoes oxidation will be a reducing agent. So it is just the opposite. So if a particular compound is undergoing oxidation, it will be a reducing agent, and if a particular compound is undergoing reduction, it will be a oxidizing agent. Let us look at one more equation to better understand the concept of redox reaction. So in this equation also we have to identify the part that is undergoing oxidation, which part is undergoing reduction, and we have to identify the oxidizing agent as well as the reducing agent. So looking at the equation, we realize that manganese oxide is a oxidizing agent because it is the one that is providing oxygen. So we can straight away say that manganese oxide is oxidizing agent, and hydrochloric acid will automatically be a reducing agent. Manganese oxide will lose oxygen, this particular will gain oxygen. So we have already identified oxidizing agent and reducing agent. Now we know that a reducing agent will always undergo oxidation, the opposite. So hydrochloric acid is agent is undergoing oxidation to chlorine. So this part, with the help of arrow mark, we will show it as oxidation. Starting with hydrochloric acid, it will lose hydrogen. Removal of hydrogen is also oxidation. Oxidation has two important definitions. One is it's a type of reaction where oxygen is added or hydrogen is removed. In this case, hydrogen is removed. Therefore, oxidation. And oxidizing agent will undergo reduction reaction. So, manganese oxide MnO2 will undergo reduction to manganese chloride. Reduction. That is it. We have studied another redox reaction. Now that you have understood oxidation, reduction reactions, let us look at where do these oxidation reactions take place in our everyday life. We have two examples. One is corrosion, second one is rancidity. Let us start with corrosion. Corrosion, as you know, when we leave any metal surface exposed outside to atmosphere, it undergoes corrosion. For example, when we place iron nail outside, it combines with oxygen in the atmosphere, undergoing what is called as corrosion. Here, oxygen is added to iron, which means iron is oxidized to give you iron oxide, which is nothing but rust. Though chemically for rust formation to take place, there should also be moisture, that is water, thereby giving the formula of rust as Fe2O3 dot 2H2O. So this is your corrosion. We know that corrosion is a highly wasteful process because if iron or other important metals get corroded, it can bring huge loss to the economy. Not only that, it can also cause structural instability, making structure weak. So what can we do to prevent corrosion? All we have to do is cut off the supply of oxygen. So we can achieve that by either oiling or greasing the surface of metals. Not only that, we can also go for painting. So when we coat it with the paint, it will reduce the exposure to oxygen. Another popular technique is galvanization, wherein a less expensive metal, for example like iron, is coated with a more expensive metal like zinc, because zinc is more reactive than iron. Therefore, zinc will form a coating which will thereby protect the inner iron from rusting. That is how we can prevent corrosion. The second example for oxidation phenomenon is rancidity. You would observe this when we keep your chips packet opened outside or any sweet made out of oil. Basically, any oily food, when we leave it outside, it will react with the atmospheric oxygen. It will undergo oxidation, thereby producing a bad smell known as a rancid smell. Very bad. The phenomenon is known as rancidity. So, when food containing oil undergoes oxidation, it produces a rancid smell. The phenomenon is called as rancidity. So, what can we do to prevent rancidity? We can go either for physical techniques or we can go for chemical techniques. In physical techniques, it's very simple. Keep the food closed inside airtight container so that any air does not enter, thereby cutting the supply of oxygen. We can also go for refrigeration, which will also prevent oxidation. In chemical techniques, we can add the food with antioxidants. These are compounds that will absorb oxygen if present inside, therefore preventing oxidation. Vitamin C is a good example for antioxidant. And another mechanism is flushing nitrogen gas. This is most commonly seen in chips packets. For example, any potato wafers or chips that you get, you will see it is filled with air. That air is nothing but nitrogen gas. So during the manufacturing process, they flush it with nitrogen so that all the air inside comes out, which is now replaced with nitrogen gas. Therefore, cutting off any oxidation. Not only that, nitrogen least reactive gas, so it will not cause any adverse reactions with the food itself, therefore preventing rancidity. So that is about corrosion and rancidity. With that, we complete the first chapter in chemistry, chemical reactions and chemical equations. Thank you.